Hi, in this video, we're going to demonstrate how OpenVision Pro works and how to configure it. OpenVision Pro is a centralized network management software that allows users to monitor, configure, and manage multiple network devices from a single platform. It helps simplify network administration by providing device discovery, topology visualization, alarm management, performance monitoring, and remote configuration capabilities. After you have successfully installed OpenVision Pro, launch the application. You can copy the URL provided and paste it into your web browser's address bar. Then press Enter. When OpenVision Pro starts, you will see the Sign Up page. Please input your user ID and password, then click Sign Up. After signing in for the first time, the system may prompt you to log in page. Please input the user ID and password you just created. Then, click Login. Now, let's start by scanning and adding devices into OpenVision Pro. First, click Add File. Enter a file name. In this demo, I will use OpenVision Demo as the file name, and Demo1 as the description. Then click Next. On the next page, you can discover devices in two ways. Add devices manually by entering each IP address one by one or search devices by an IP address range. For this demonstration, we will use the IP search range option. Enter the starting IP address as 192.168.10.10 and the ending IP address as 192.168.10.50. Then click Search All. OpenVision Pro will begin scanning the network and searching for compatible devices within the specified IP address range. Once the scan is complete, all detected devices will appear in the search list table. In this demo, I have 9 switches in the network. Next, select the devices that you want to add to OpenVision Pro. After selecting the devices, click Add. All selected devices will be moved to the device list, indicating that they will be managed by OpenVision Pro. Once you have confirmed the device list, click Next to continue to the next step. Now, OpenVision Pro will generate a topology preview based on the devices we selected. In this topology preview, you can see all 9 switches that were added to the project. Each switch is displayed with its device icon and its IP address shown below the icon. If everything looks correct, click Finish. Okay, now let's start with the topology view. The topology view provides a graphical representation of your network and allows you to organize devices according to their physical locations or network architecture. In this demo, we can arrange the switches based on their redundancy groups. For example, switches 1.21, 1.22, and 10.23 are running ORing redundancy, so we place them in the center of the topology. Switches 1.31, 1.32, and 1.33 are running O-chain redundancy, so we place them in the upper left corner and serve as O-chain 1. Switches 1.41, 1.42, and 1.43 are also running O-chain redundancy, so we place them in the lower right corner and act as O-chain 2. You can freely drag and reposition devices to create a topology layout that best represents your actual network deployment. The topology view also automatically displays the connections between neighboring switches. For each link, OpenVision Pro shows which switch is connected to which neighbor, the local port number, and the neighbor port number. This makes it easy to identify how devices are interconnected throughout the network. Then click Save File after you arrange the switches. In addition, backup or standby links are displayed as dashed lines, allowing you to quickly distinguish between active forwarding paths and redundant backup paths. This visual representation helps network administrators understand the network structure, verify redundancy configurations, and quickly troubleshoot connectivity issues. On the left side of the screen, click the arrow button to expand the device panel. After clicking it, OpenVision Pro will display all devices that belong to the current project. This panel provides a quick overview of every device being managed within the network. You'll also notice a status indicator next to each device. If it shows green dot, the device is online and currently connected to the network. Open Vision Pro can reach with the device normally. If red dot appears, the device is offline or disconnected from the network. Open Vision Pro is unable to communicate with the device at this time. This allows administrators to quickly identify which devices are operating normally and which devices may require troubleshooting. You can also click Edges. The Edges function displays all the connections between devices in the project. In this panel, you can see which switch is connected to another switch, the local device and its port number, the neighbor device and its port number, and the status of the connection. Instead of checking each switch individually, you can quickly view all device-to-device connections from a single page. Okay, now let's perform a test to see what happens when a network link goes down. In this example, we will disconnect the link between switch 1.22 and switch 1.23. As soon as the link is disconnected, the topology view automatically updates the connection status. You can see that the affected link changes to red, indicating that the connection is down. At the same time, the redundancy mechanism detects the failure and activates the backup path. The topology will also indicate that a network event has occurred. To view more details, click the notification button in the upper right corner of the screen. The notification panel will display an event message showing that the link between switch 1.22 and switch 1.23 has gone down. This allows administrators to quickly identify the affected devices and take appropriate action. After reviewing the notification, click Check All, then return to the topology view. You will notice that the backup link has become active. Previously, the backup path was displayed as a dashed line, indicating a standby connection. Once the primary link fails, the backup path becomes an active forwarding link and is displayed as a normal connection line. Now, let's reconnect the link between switch 1.22 and switch 1.23. Once the physical connection is restored, Open Vision Pro will automatically detect that the link is back online. In the topology view, the red line will change back to a normal connection line, indicating that the link is operating correctly and traffic can once again be forwarded through the primary path. At the same time, the redundancy protocol will restore the network to its normal state. The backup link, which became active during the failure, will return to standby mode and be displayed as a dashed line again. Now, let's test what happens when multiple network links fail at the same time. In this example, we will disconnect 3 links. The first link is the link between switch 1.42 and switch 1.43. The second link is the link between switch 1.22 and switch 1.23. And the This Road link is the link between switch 1.32 and switch 1.33. As each link is disconnected, Open Vision Pro immediately detects the failure and updates the topology view. You can see that all affected connections are displayed in red, indicating that those links are currently down. At the same time, Open Vision Pro generates event notifications for each link failure. To review these events, click the notification button in the upper right corner of the screen. You will see separate notifications showing the status of each disconnected link, allowing you to quickly identify which devices and connections have been affected. After check all the notifications, return to the topology view. You can now see that the backup paths have been activated automatically. The redundancy protocols detect the failures and switch traffic to the available backup links, helping maintain communication between devices even when multiple links fail simultaneously. Even during multiple link failures, you can quickly identify the affected connections, review event notifications, and confirm that backup paths have taken over network traffic. Now, let's reconnect all of the previously disconnected links. Once the physical connections are restored, Open Vision Pro automatically detects that the links are back online. We can view detailed port information for each device directly by simply right-click on a device icon, then select Port Status. In this page, you can clearly see which ports are connected or disconnected. If a port is connected to another switch, Open Vision Pro can also display detailed neighbor information, including the neighbor switch IP address and MAC address, the connected port number on the neighbor switch and neighbor device system name. Instead of checking each device individually, you can quickly identify link relationships and verify connectivity from a single interface. If you need to perform configuration on a specific device using the web interface, you can simply right-click on the switch icon, then select Open in Web. After clicking it, the system will automatically redirect you to the device's web-way login page. From here, you can directly log into the selected switch and perform full configuration changes. In addition, under Topology View, OpenVision Pro provides several useful management tools that can be accessed by right-clicking on a switch icon. Let's take a look at these functions. Open SSH. This function allows you to access the selected switch through an SSH session. By clicking Open SSH, you can directly open a secure command line connection to the switch for configuration and troubleshooting tasks. Open Ping. This function allows you to send ICMP ping requests from your PC to the selected switch. It is useful for verifying network connectivity and checking whether the device is reachable on the network. Event Log in Web. This function opens the switch's event log or syslog page in the web way. From here, you can review system events, warnings, alarms, and other log messages generated by the switch. Test SNMP. This function checks the SNMP communication between the switch and OpenVision Pro. It helps verify that the SNMP configuration is correct and confirms that OpenVision Pro can successfully collect monitoring information from the device. Local Alert. When managing many switches, it can sometimes be difficult to identify which physical device corresponds to a specific icon on the topology. The Local Alert function helps solve this problem by triggering a buzzer on the selected switch. This allows you to quickly locate the physical device in the field or inside a control cabinet. Remove Device. If a device is no longer needed in the project, you can select Remove Device to delete the switch from the current OpenVision Pro project. Please note that removing a device from the project does not delete its configuration or reset the switch. It only removes the device from the current project database and topology view. As you can see, OpenVision Pro provides a variety of management and troubleshooting tools that can be accessed directly from the topology view, making network administration faster and more efficient. Now, let's move to the second subcategory in OpenVision Pro, Traffic Monitor. The Traffic Monitor function allows you to monitor the real-time network traffic of individual ports on your switches. For this demonstration, I have 7 different switch series for testing. One of the switch series uses 3 switches, so the total number of switches in this project is 9 switches. Let's select one of the switches, switch 1.21. After selecting the switch, you will see all available ports on the device. Now, click port 1. OpenVision Pro will display the real-time traffic statistics for port 1. It shows input rate and output rate of port 1. These values are updated in real time, allowing you to monitor network utilization and traffic behavior on the selected port. If you select another port, such as port 2 or port 3, OpenVision Pro will display the real-time input and output traffic for that specific port as well. Next, let's configure a traffic alarm threshold. Click the Settings page. For port 1, set input rate limit to 100 kilobits per second and output rate limit to 150 kilobits per second. Then click Save Settings. Now return to the real-time traffic page. You will notice that the graph now includes alarm threshold lines corresponding to the configured limits. Once the traffic rate reaches the configured traffic limit, OpenVision Pro will automatically generate an alarm. You can view these alarms by clicking the notification button in the upper right corner of the screen. The notification will display detailed information, including which device triggered the alarm, which port exceeded the threshold, and whether the alarm was caused by the input rate or output rate. After reviewing the alarm information, you can delete the notification to keep the notification list organized. Please note that deleting the notification only removes the alarm message from the notification panel. Another subcategory in OpenVision Pro is Host Monitor. The Host Monitor function is designed to monitor the availability of network devices. It periodically checks whether a device is reachable on the network based on the configured polling interval and timeout settings. This allows administrators to quickly identify devices that become unreachable or go offline. To begin, click Option, then select Manage Device. There are 2 ways to add devices. First, add devices individually by entering their IP addresses one by one. Second, add devices using an IP address range. For this demonstration, I will enter the IP range from 1.22 to 1.30. From the search results, you can select which devices you would like to monitor. For this example, I will only select 1.22 until 1.25. Then click Add to Device List. Next, I will repeat the same process for the ranges 1.31 to 1.33 and 1.41 to 1.43. Then add to device list. After selecting the desired devices, click Submit. Now the host monitor page displays all devices that have been added to the monitoring list. To begin monitoring, select all devices and click Start. As you can see, most devices are reachable. However, switch 1.24 and switch 1.25 are shown as offline because these devices are not currently connected to the network. Their status appears as offline, and the connectivity test has failed. Click Stop to stop monitoring. Since switch 1.24 and switch 1.25 are not part of the network, we can remove them from the monitoring list. Now let's perform the test again. Click Clear Tests to remove the previous test results. Select all remaining devices and click Start. This time, all devices are online and reachable. Click Stop to stop monitoring. Next, let's configure the monitoring parameters. Click Options, then select Configuration. The first tab is Mode. Here, you can choose different monitoring modes, such as Timer, Stop after a certain period, and Test Limit, Stop after a specified round. The second tab is Polling Settings. For this demonstration, I will set the polling interval to 500 milliseconds and the timeout to 100 milliseconds, then click Confirm. Now let's start monitoring again using the new settings. Select all devices and click Start. Open Vision Pro is now monitoring all devices using the updated polling configuration, and all devices are reachable. Click Stop. You can also monitor only specific devices. For example, I will select switch 1.41 until 1.43. Click Options, then select Restart. Now only these 3 devices are being monitored. You can also add descriptions to make device identification easier. Click Edit on a device. For example, for switch 1.43, I will enter the description, CCTV3. Click Save. Now the description will appear in the host monitor display. Open Vision Pro can also display syslog messages related to monitored devices. Simply click the message button to view system logs and events. For reporting purposes, you can export or import monitoring records in CSV format. Host Monitor also has a filter function, helps you quickly find specific devices. For example, 1. Search by IP address, such as 1.21. 2. Filter devices by status, such as online or offline. 3. Search by description, such as CCTV 1, CCTV 2, or CCTV 3. These filtering options make it easy to manage large numbers of devices in your monitoring environment. Next is Commander. Before we begin, I will select switch 1.33 as an example device. The Commander feature allows you to perform remote management tasks on your devices, such as rebooting a switch, upgrading firmware, backing up configurations, and restoring configurations. The first action available in Commander is cold reboot. To reboot the switch, simply click the reboot button. After the reboot command is sent, the current status changes to running, indicating that the task is being executed. Once the reboot process is completed successfully, the current status changes to success. This confirms that the switch has completed the cold reboot operation. There are also any other actions that Commander can execute, such as firmware upgrade, config backup, and config restore. Let's perform a firmware upgrade using Commander. Currently, switch 1.33 is running kernel S12.168. We can verify this by accessing the switch through its web and checking the firmware version in the system information page. Now return to Commander. Click Apply Setting. For the transfer protocol, select TFTP. Then enter the host IP address of the TFTP server and the firmware file name that will be used for the upgrade. After entering the information, click Confirm. Next, go to Actions and select Firmware Upgrade. Review the upgrade information, then click Confirm. Commander will begin the firmware upgrade process. The current status changes to running, indicating that the firmware is being uploaded and installed. Once the process is completed successfully, the current status changes to success. As you can see, the firmware version has now changed from kernel S12.168 to kernel S12.167. For verification, we can access the switch again through the web. In the system information page, the firmware version is now displayed as kernel S12.167, confirming that the upgrade was completed successfully. The next action available in Commander is config backup. This feature allows you to remotely back up the switch configuration. Simply click Config Backup. Commander will retrieve the configuration file from the switch and save it to the configured TFTP server folder on the host PC. This makes it easy to back up configurations from multiple switches without logging into each device individually. The other action is Config Restore. This feature allows you to restore a previously backed up configuration file to a switch. First, enter the backup file name in the Restore Configuration file field. Click Confirm to save the settings. Then go to Actions and select Config Restore. Commander will upload the configuration file from the TFTP server and restore it to the selected switch. One of the most important features in OpenVision Pro is the MIB browser. The MIB browser allows you to communicate with a switch using SNMP. You can retrieve information from the switch or modify switch configurations using operations such as get next, get bulk, walk, set, and others. For this demonstration, we'll use switch 1.33. First, enter the switch IP address in the address field. On the left side, you'll see the MIB tree, which contains all supported SNMP objects. Let's start with a simple example. Expand the MIB tree and select System Description. Once selected, the corresponding OID, or Object Identifier, will automatically appear next to the IP address field. Now choose the Get operation and click Start. The result table displays the returned information, including the OID, value type, and the IP address and port of the target device. Let's try another example. Select System Object ID, choose Get, and click Start. The MIB browser retrieves the switch's object ID and displays the information in the result table. In the same way, you can retrieve other system information such as system uptime and system name. Now let's retrieve system contact. Select System Contact, choose Get, and click Start. As you can see, the value is empty because the system contact has not yet been configured on the switch. Now let's configure it using the MIB browser. Select Set, then click Start. A configuration window will appear. Since we're entering text, set the data type to octet string. For the value, enter admin 112233, then click Save. Now let's verify the configuration. Select Get again for System Contact, then click Start. This time, the returned value is admin 112233, confirming that the configuration was written successfully. To verify it on the switch, open switch 1.33 through the webway. Go to System Information, and you can see that the system contact has been updated to admin 112233. Currently, the location field is empty. Next, let's configure the system location. In the MIB browser, select System Location. Choose Set, then click Start. Again, select octet string as the data type. For the value, enter Station 1, then click Save. Now perform another Get operation for system location. The result shows that the location has been successfully updated to Station 1. Let's verify it one more time from the switch's webway. Refresh the system information page. As you can see, the system location has also changed to Station 1. Besides viewing and configuring MIB objects, you can also export the MIB result table for reporting purposes. If needed, you can clear the result table by clicking Delete. Finally, click Advanced Properties to configure the SNMP communication settings. Here you can configure the SNMP port, the read community, the write community, and the SNMP version, including SNMP v1, v2c, or v3, depending on your network requirements. OpenVision Pro also provide a system log function. The system log records all important events and operations that occur within OpenVision Pro and its managed projects. It helps administrators monitor system activities, troubleshoot issues, and keep an audit trail of management operations. Here, you can see all recorded log entries. Each log contains the following information. 1. Date and time, when the event occurred. 2. Target, the user or devices that related to the event. 3. Description, details of the operation or event. 4. Severity, the importance level of the event. 5. Status, whether the operation or the current networks was completed successfully or failed. If you need to generate a report or keep a backup of the logs, simply click Export as CSV. The system exports all current log records into a CSV file, making it easy to review or analyze the logs using spreadsheet software. You can also customize which events are treated as more important. Click System Log Setting. Here, you'll find a list of different log categories. For each category, you can configure the severity level as high, normal, or low. After making your changes, click Save to apply the new log severity settings. And that's it. We've now covered all the major features provided by OpenVision Pro, including topology management, traffic monitoring, host monitoring, device management with Commander, MIB browser, and the system log. One last thing that very important is account management. Account management is an important feature because it allows you to control who can access the system and what permissions each user has. Currently, I'm logged in as the administrator. OpenVision Pro supports 3 account types: administrator, manager, and user. Let's begin with the administrator account. Since this is the first installation, we're still using the very first administrator account. For security reasons, we can change the password periodically. Click the Edit button under the Action column. Enter your current password, then enter your new password, re-enter it to confirm, and click Save. Now let's verify the new password. Log out from OpenVision Pro. First, try logging in using the administrator account with the old password. As expected, the login fails because the password has been changed. Now enter the new password. The login is successful. Please note that only the administrator has permission to create, edit, or delete user accounts. Next, let's create a manager account. Click plus Create Account button. Enter a user ID, for example manager A, create a password. Then select Manager as the account type. Click Create. Now log out from the administrator account. Log in again using the Manager A account and its password. As you can see, we're now logged in as a manager. A manager can perform almost all project-related operations, including monitoring devices and modifying project configurations. However, a manager cannot modify global system settings, such as changing the OpenVision Pro license key or other administrator-level configurations. For example, in the topology view, I'll move switch 1.31 to another position and save the project. The operation is successful, demonstrating that the manager account has permission to edit project content. Now, log out and sign in again as the administrator. Let's create a user account. Click plus Create Account. Create a new user ID, for example user A, enter a password. Select user as the account type. Then click Create. Now log out from the administrator account and sign in using user A. Once logged in, let's open the topology view. I'll try moving switch 1.31 back to its original location. When I attempt to save the changes, OpenVision Pro displays an access denied message. This is because a user account has read-only permissions and cannot modify project configurations. Now let's log out and sign back in as the administrator. We'll move switch 1.31 back to its original position. This time, the operation is completed successfully because the administrator has full access privileges. If an account is no longer needed, simply click the delete button next to that account to remove it from the system. Finally, after completing your monitoring tasks, you can close the current project tab, for example, the OpenVision demo project. If you want to continue working on the project later, simply click Open File, select the OpenVision demo project file, and click Open. OpenVision Pro will reload the entire project, including the saved topology, monitored devices, and project settings, so there's no need to configure everything again. And that's it. Thank you for watching this complete OpenVision Pro demo series. We hope these videos help you deploy and manage your industrial network more efficiently.